Today we're talking about rate of change and starting point, which are properties of functions. We're mainly going to focus on linear functions today, so things that have a constant rate of change, but next week we'll look at some that are not linear as well. Okay, so when we're dealing with linear functions, if it's an equation, we know that it has to be in the form of, or it should be able to made into the form of y equals mx plus b. Sometimes you might see that reversed, like y equals b plus mx, and that's fine too. The rate of change will be the number that is next to x, because it is what's happening over and over. So we'll write that equation again. The starting point would be the b, and that is a thing that happens once. And when we wrote equations with unit 3, we saw the same thing. Happens one time, and it's our starting point. So the number that's by itself is going to be our starting point, because it happens one time. And for a table, so we find the change in the x and the change in the y by writing those brackets and then finding out how much we're adding or subtracting over and over. We did this last week. We did linear and nonlinear functions. And so whenever we are doing rate of change for a table, we're going to start by doing the same thing we did last week, but then we're going to put it together in a fraction. It's going to be the change in y over the change in x if it's a linear function. We need to make sure that we simplify the fraction if we can. For the starting point on a table, it's going to be where the x is equal to 0. So whenever you see x equals to 0 on the table, that will be your starting point, and it's written as a point, 0, comma, whatever number that goes with. Same thing goes with an equation. We could plug in 0 for x, and we would get the same type of thing happening, but it's easiest to just look at the equation and see the number that's by itself as your y-intercept. We're going to determine the rate of change from the following equations. Remember, the rate of change for a linear equation in y equals mx plus b is the m, the number that is in front of the x. So for this first one, it's going to be -4. We're going to say m is equal to -4. This next one is 8. And the last one is 1/3. So we'll write that as a fraction. Now we're going to determine the starting points. Remember, it's the number that's by itself. We're looking at something in y equals mx plus b form. We often call that number the constant. It does not have a variable next to it. So for this equation, it would be 10. So we're going to write it as a point 0, 10. The next one, the number by itself, is -3. Take the sign in front. So we write that as a point 0, -3. And the last one is the 700 is by itself. So it's at 0, 700 is where it starts. Now we're going to determine the rate of change and starting point from the tables. Okay, rate of change, we'll do the same things we did before. I'm going to find how the x is changing. That's +1, +1, +1. and plus 1, and then the y is going, oh, that is plus 5, plus 5, plus 5, and plus 5. So it's a linear function for sure. We know that because it has a constant rate of change. As x goes up by 1, y goes up by 5. And so when we write that, we write change in y over the change in x, which would be 5 over 1. We can simplify that to just 5. My starting point is where x equals 0. And so my starting point is 0, negative 5. Make sure you pay attention to where x is 0, not where y is 0. One more, we're going to do the same thing. So it should be a linear function, but we're going to find our rates of change. So minus 1, minus 1, minus 1, and minus 3, plus 3, plus 3, plus 3, and plus 9. So it just looks like it skips some numbers here. You really only need one pair of numbers. So if we wanted to choose like 9 over negative 3, that would simplify. We divide both the top and the bottom by 3. It would simplify to the same thing, 3 and negative 1. So it really didn't matter. So we write this as a change in y over the change in x. My change in y is 3 and my change in x is negative 1. So it's going to be 3 over negative 1, which we can simplify to negative 3. And then the starting point is kind of tricky because you don't actually see it in your table. So you'd have to add it when x is 0. And we're going to continue this table. So that would be minus 3. But when x goes down by 3, the y goes up by 9. So that would have to be 30. So my starting point here would have to be 0, 30. This point right here.